Okay, so Workplace Apprenticeship 30, this is 5.1 Part 2. This is 2 of 2. So we'll finish off 5.1 today. Again, in Chapter 5, we've been talking about this sorts of thing where we, oops, I guess right here, properties of geometric figures. We talked about triangles. We've talked about right triangles and SOHCAHTOA. Did some questions regarding that. We also have... I guess just looked at triangles and right triangles. So, and properties of triangles, identifying classes of triangles or classifications based on angle measure and based on side length. So we've looked at these types of triangles. So today we are going to look at example 4, and we're going to explore more properties of triangles and use those properties to solve problems. So example 4 says this: an asymmetrical roof. So first of all, asymmetrical. Symmetrical means it's the same on both sides, right? There would be a dividing line where one half looks exactly the same as the other. Asymmetrical, whenever you have atypical or something that starts with an A or an anti or something like that, it means opposite. So it's not symmetrical. And you can see that this roof is sloped a little bit, it's got a little bit more of a longer section there than here. And this angle measure right here looks a little bit larger than maybe this angle measure over here. So it's an asymmetrical roof, and the sections are as follows on the diagram. So we have 18 feet here from A to B, and we have 14 feet from A to D. Okay. The roof has a rise of 6 feet. So at the very center, from the highest point down to the base, forming a 90 degree, is 6 feet. So you want to sketch that into your notes here. And what we're going to do is answer these two questions. So how wide is the building? So we're looking for the section DB, this line right here, DB. And of course, DB is going to come from this section BC. Oh, you can't really see that one, sorry. BC, and also the sum of BC and CD as well. So we're going to want to find those two sections, okay? All right, so there's two different ways we can do this. So let me just clear this up a little bit. So with this section over here, the ABC triangle, this is also a 90 degree angle. And I have the height here, this side, and I also have the length of this side. Being that it's a right triangle, what property of right triangles can I use to find out this side right here? Because I can use something that we talked about last lesson. How can we find that out? Everybody? Yeah, you can use Pythagoras' theorem, right? Or the Pythagorean theorem. So yes, we can use a squared plus b squared equals c squared. And of course, a and b would be the legs of the triangle. So here we have x down here, and we have 6 here, we have 18 here. So a probably could be x, b could be the 6, and c could be the 18. So if we plug all those values in, I have unknown x squared plus 6 squared equals 18 squared. X squared equals 18 squared minus 6 squared. And we could get on our calculator. I don't expect you to know what 18 squared is, but you might. But if not, you can plug that into your calculator. It's 18 squared, 324, and minus 6 squared. Hopefully you don't need your calculator for that. That's 6 times 6, or 36. Right? So x squared equals then 288. So because that's squared yet, I have to now take the square root of both sides. Okay? So to get x all by itself, and I'll just put that over here, x now equals, let's take the square root of the answer. Use your answer button so you have to retype things out, and it's about 16.97 or 17. We'll round that up to 17, okay? 17, and that's going to be feet, okay? So x is 17. That's great. We know that. So we've got half of our problem figured out. But now I want to find this one over here, and I don't know what this is. So this is another right triangle, and I'll just maybe draw it, recreate it over here. So there's 25 degrees. This is 14. and this is 6, and it is a right triangle. So how can I find that side right there? Now is this well, I guess it is it's a right triangle, and I am given 2 sides. So there's actually 2 different ways you could find this here. You could still do Pythagoras' theorem, looks like, right? But there is another option because you're given this angle. So we could use Pythagoras' theorem because we're given 2 sides of a right triangle, and we could find for the third. But what's the other thing we could do here? Anybody see how we could use that angle? Okay, SOHCAHTOA, right? We could use sine, cos, or tan. Now, this right here, this side that's unknown, is the adjacent side, right? That's the adjacent side. So if I wanted to use this angle, I could either use, this is opposite, and this is hypotenuse. So I could use any of the trig functions that include the adjacent side and either the opposite or hypotenuse. So let's see. SOHCAHTOA, we all have to know that. And which ones include the adjacent side? Well, it's cosine or tangent. So I could use either one because the hypotenuse is known as well as the angle. So that's only the adjacent that I could find. And for tan, you see, the opposite and the angle are known. And so I could solve for A as well. So it doesn't matter which one we use there. You could use Pythagoras or the trig functions. And they both should give you the same answer. So I'm just going to use the cosine here. Just pick the first one. So cosine of 25 degrees, because you always have to use that angle there, right? Cos of 25 equals, and this says adjacent, so that's the A, we'll just call it A, divided by the hypotenuse, which is 14. So if I want to solve for A now, I multiply both sides by 14, and A here now just becomes 14 times cos of 25. And so I could just do that on my calculator, no problem. 14 cos 25, 12.688. Okay, does that sound reasonable? 12 point. Now let's round that to the nearest not 1 decimal place probably. So 0.7. 1 decimal place is usually okay to round to if you're questioning usually. Yeah. So then that means that how wide is the building? Well, now I have to add these up, right? So x and let's say, oh, that's A, x and A. I just add x and A. So the width of the building is 12.7 feet plus 17 feet. And that's going to be what? 29.7 feet. Very good. 29.7 feet. Yes?
Couldn't you just take the 17 and times that by 2?
Okay, so couldn't you just take the 17 and times it by 2? Is that what you said?
Yeah.
Okay, good question. The quick answer is no. Well, this is a square. Yeah, the building is a square.
And the triangle is square.
But the triangle up top there, remember this is asymmetrical. Asymmetrical. So what that means, again, is that this... Okay, so if it was symmetrical and the roof looked like this, where this was the same as this and this was the same as this, then yeah, we could just find 1 and times 2. But this is not how this roof is. The roof is more like this, right? So in this case, these are not symmetrical. So that means that this side right here is not the same as this side. All of them are different. So we do have to solve that separately. But good question, though. Yeah, most roofs are nice and symmetrical, right? So you're right. You'd be able to maybe find half and then just times 2 for most situations. Yeah. Okay, so let's just check on the next page here. I've got the solution. So what did we say it was? 29.7. Okay, so here's the solution on the next page here. And of course they find 17 there. And they used Pythagoras again to 12.6. I guess we rounded to 12.7. Should have been 12.7. But anyways, 29 points. Yeah, there we go. So we're good. Yeah, we're good. We rounded a little bit differently, but yeah, I'm not sure why that's different. But anyways, that's good. Okay, we'll just call that good. All right, let's take a look at B here, I guess. What's B? B says, oh, classify ABC, so that's this triangle over here, the first one on the left, and ACD, so ACD is the one over here on the right. Oops, oh my goodness, over here. And then also ABD, so that's the big triangle here. So classify that by angle measure and by side length. So let's just talk that out, okay? ABC by angle measure, what kind of triangle would that be? ABC. Well, it's got a right angle in it, so that's our cue. That's a right triangle. Okay? And of course, ACD is also a right triangle. What about ABD? Okay, let's take a look at this bigger triangle. And that would be like this one right here. ABD. So this big triangle, how could I classify that according to its angle measure? Yes, very good. Obtuse. Now, we don't have confirmation, I guess, that is obtuse, but it certainly looks like it is, right? So that's what you would say. Yeah, obtuse. Very good. That's the one you want to call it. Very good. Okay, so by side length here, let's see, side length. So what about this one by side length? That's 6, this is 12.7, that's 14. So what would we call this ACD here? What's the name of that one, you remember? It's not isosceles, not equilateral, that's right. Let's go back there, where were those? Okay, so yeah, I think you're right there. Let me just, oh my goodness. Where is this? Bleh. Oh, here we go. So by side length, yeah, if they're all separate, it's this scalene. That's right. If two sides are the same, it's isosceles. If all the sides are the same, it's equilateral. So yeah, you got that right. That's a scalene. And this one, 18, 17, and 6, that's also a scalene triangle, looks like. All right, so let's take the moment to I'll hand out these questions here for you. Okay, so with this question number 7 here, we're going to get to practice our skills here. So you should notice in this diagram that we have some triangles here. This looks like a right triangle right here. Okay, that's a right triangle. And we have all sorts of other triangles. We have an isosceles triangle right here that I'm outlining, because those two sides are the same. That means those two angles will be the same. And I guess that's the main thing. So the question is, how long is the bridge? Oh, how long is the bridge? So it looks like we need to add up this plus this plus this and this and this and this. Now they're all the same length. See that? Because they all have 2 tick marks on them. That means they're the same. So if we could find out the length of one of them, then we could just multiply by 1, 2, 3, 4, 5, 6. Okay? So what do we know? We know that this is 11.3, and it looks like over here, this 8 feet, looks like that's this one. So I'm going to redraw this triangle. 11.3 feet here. This one is 8 feet, and it is a right triangle. Okay, that's a right angle right there. So I don't have to find the angle measures, but what I do have to find is I have to find this side. So let's see, it's a right triangle, and we've got 2 sides of the 3. What's the first thing that comes to your mind we can use to find that third side? Yeah, Pythagorean theorem. Very good. Yeah, that's the one. Okay. So again, these are the legs of the triangle. So we're going to do let's say this is x, right? So let's say this is x squared plus 8 squared equals 11.3 squared. X squared equals 11.3 squared minus 8 squared. So you can get that on your calculator there, and you can do all that all at once. 11.3 squared minus, now 8 squared is 64. You may know that. So, and that gives us 63.69. 63.69. And we take the square root of that, square root of the answer there. That gives us 7.9, or that's going to be pretty much 8, right? 8. Okay. So it looks like, because this is 8 and this is 8, it looks like this is actually an isosceles triangle. Now we know that. Okay. So yeah, if you put 7.98 instead of 8, that would be fine. I think we can round to one decimal place, like I mentioned, which would take that to 8. Technically, it's not exactly 8, but that's close enough. I'll accept that. So now, how long is the bridge? Well, I have to do now 8 times 4, don't I? Sorry, times 6, not 4. Right? Because didn't we say there was 6? 1, 2, 3, 4, 5, 6. Yeah. So 8 times 6 is 48. And of course, I can't just stop at 48. I have to, it's 48 what? What are the units here? Not centimeters, sorry. It's this little tick mark means feet. 48 feet. Okay. Right. Any questions there? All right, so let's take a look at letter B then together. So the angles, the interior angles of ABC. Okay. Interior angles. Well, this is a 90 degree. Guys, watch this. This is pretty easy actually. We have to do very little calculation here if we use our brains. So you just use your head and what you know about these triangles. Okay, this is 90. This is an isosceles triangle now. So these angles have to be the same. So if this is like, let's say this is y, and this is y, we have 2y plus, what size is this angle? 90 equals 180. So because this is an isosceles triangle, I know that each of these are the same. So if they're an unknown value, they're both the same. So that's y plus 90 equals 180. Or 2y plus 90 equals 180. Yeah, so 2y is going to equal 90 when we subtract 90 from both sides. And y is going to be 45 degrees. So we got 45 degrees, 45 degrees, and 90 degrees. Now ABC, let me just see here. There's okay. So yeah, this is a 90. Excuse me. It's actually talking about ABC here. ABC. So what we've done is we've calculated this. Right? That's not quite the same, so we got to read that careful. So that's my bad. But we can figure this out pretty easily. This is a 90, this is 45, and this is 45. Right? So that means that this is 45 and this is 45. So what is 45 plus 45? Yeah, it's 90. So do you guys see that that's actually the same kind of triangle as this one? They're similar triangles. One is just larger than the other, but they're the same shape. So 45, 45, 90, and also 45, 45, and 90. So this is actually true for the angles of ABC as well, but it wasn't this angle that we initially looked at, this triangle. Okay, so that may be a lot at once there, I'm not sure, but do you have any questions about that? Okay, all right, so you have in your hands there the rest of those questions. So I'll ask you to take the rest of this class. You have about half the class to finish these build your skill questions and the practice questions, okay? So you have, let's see, 1, 2, 3, 4, 5, 6 questions to do for the rest of this class before tomorrow's class.